Hello everyone, my name is Patricia Nicole Vivaswell and I'm from ECE 3A. So my topic would be about stress versus strain, the big four mechanical properties. The first one would be tensile test. It is pulling force to a material and measure the specimen's response to the stress. It is used to determine how materials will behave under load tension. In a simple tensile test, a sample is typically pulled to its breaking point to determine the ultimate tensile strength of a material. Tensile test determines how strong a material is and how much it can elongate. So these are the big four mechanical properties. The first one is elastic modulus. The second one is yield strength. The third one is tensile strength, and the fourth one is ductility or strain failure. Elastic modulus. The ratio of the force exerted upon a substance or body to the resultant deformation. It is the measure of an object or substance resistance to being deformed elastically when stress is applied. It is also defined as slope of its stress-strain curve in the elastic deformation region. So as you can see, the E here is called Young's modulus or modulus elasticity. At the top, it is called the stress, and at the bottom, it is the strain. Yield strength, defined as the stress at which a predetermined amount of permanent deformation occurs. The graphical portion of the early stages of a tension test is used to evaluate yield strength. When a material is stressed by an amount that is less than the material's yield stress, it will only undergo elastic irreversible strain, and no permanent deformation of the material will occur. The level of stress that corresponds to the yield point is referred as the yield strength of the material. Tensile strength is the ability of a material to withstand a pulling tensile force and refers to the breaking strength of a material when applying a force capable of breaking many strands of the material simultaneously at a constant rate of extension or load. The resistance of a material to breaking under tension, and it is also defined as the physical property of different building materials and how they can withstand tension. So these are the strength and stiffness differences. The strength of a substance is the capacity of that substance to withstand great force or pressure without breakage or plastic deformation, while stiffness is the rigidity of an object. For the strength, describes the ability of an object to withstand stress without breaking or plastic deformation. And for the stiffness, describes the ability of an object to resist the deformation when a stress is applied. So next is the strength, related to the physical failure of a substance. And while the stiffness refers to the related to the functional failure of a substance. In the strength, associated with both elastic and brittle substances, and in the stiffness, mainly applicable to elastic substances. And for the different types of strength, it includes impact strength, tensile strength, fatigue strength, and yield strength. And for the stiffness, the different types include rotational stiffness and axial stiffness. Ductility, the ability of a material to sustain a large permanent deformation under a tensile load up to the point of fracture, or the relative ability of a material to be stretched plastically at room temperature without fracturing. It is the ability of metal to be pulled into a thin wire or a band. One of the basic example of this is a wire. So for the summary, The first one would be the tensile test. It is the source of what we call the big four mechanical properties. First of all, the elastic modulus, then the yield strength, which is that breaking point between elastic and plastic behavior. Then the tensile strength, that maximum value of engineering stress during the overall test. And the strain and failure, sometimes called ductility. All of all four of those big four properties are widely tabulated in the literature. In addition, there is toughness, the area under the stress versus strain curve. While that may not be widely tabulated, it's a very important concept. And then finally, engineered polymers are those materials that have adequate strength and stiffness to allow them to be substituted for structural metals. That's all, and thank you for listening.